So you might have heard this term, isotopes. They are just the same element. They have the same atomic number, but they have a different mass number. Like we have chlorine, whose atomic number is obviously 17, and we know that its mass number is 35, but there also exists molecules of chlorine whose atomic number is the same, 17, but mass number is 37. This is comparatively less existing in lesser amount than chlorine 1735. So that is why these two are isotopes, because they have the same atomic number and different mass number. So what was the problem? The problem was that Mendeleev, if you had remembered, Mendeleev had arranged the elements according to increasing mass numbers. So isotopes were not discovered that time, so he was safe. But when isotopes were discovered, how could you place isotopes? I mean, he knew only chlorine with 17 and 35. If he gets another chlorine with 17 and 37, how would he place them? Can he place them side by side? Like 1735 and chlorine 1737. Can he place them side by side? No. How can he place them side by side? They are the same element. They have to have the same properties. They have to be in the same group if they have the same properties. So they cannot be placed side by side, or I mean along 35 and 37 there is maybe leaving one or two gaps. They had to be placed in the same group. But if they were placed in the same group, he would have to place it below this 17 and 37. And of course, you cannot have so many elements over here and over here. I mean, not over here so many, over here and again over here, with atomic masses lying between 35 and 37. I mean, after chlorine, there must be there would be an element having an atomic mass, I guess, more than 37. So after that, you cannot go up till, so let's say 45, 50, and then come back to 37. Cannot do that. And moreover, this place is already occupied by bromine. So isotopes were very much a problem when they were discovered in the Mendeleev's periodic table. So the disadvantage was that when they were discovered, they were not able to find themselves a place. So the isotopes could not be adjusted into the Mendeleev's periodic table. And thirdly, another very major problem was that when Mendeleev had discovered this periodic table, he did not really, most of the elements were not discovered by that time. I mean, many elements were not discovered by that time, which were discovered much later. And in Mendeleev's periodic table, the atomic masses, as he had arranged them in, did not increase in a regular manner. The atomic masses did not increase in a regular manner because there were not many elements discovered. So there could be an element between two elements having consecutive, if there was an element A having an atomic mass 17 and there was a B having 20, maybe 21, then you could have had so many elements between A and B which are not discovered. And then in his periodic table, these atomic masses did not increase in the regular manner. So you cannot really say that how many elements would be discovered between two elements, because two elements had sometimes two elements had a considerable gap between their atomic masses. So there can be many elements coming in between these two elements when they are discovered. So how to accommodate them into the periodic table? That was another very important disadvantage of Mendeleev's periodic table, was that the atomic masses did not increase in a regular manner. So it was difficult to predict how many elements could be discovered between two consecutive elements in the periodic table, Mendeleev's periodic table. So these were the three main disadvantages of Mendeleev's periodic table, and the modern periodic table, which we have discussed, resolves all these three disadvantages. It provides a solution for all the disadvantages. Position of hydrogen, you might remember, hydrogen is floating in the modern periodic table. You get a very common question sometimes, that what are the disadvantages of Mendeleev's periodic table, and how did modern periodic table combat these disadvantages or provide a solution to these disadvantages? How can you compare the two tables? So it provided a solution for all the three disadvantages. First thing was that the position of hydrogen was placed with the alkali metals in Mendeleev's periodic table, but in the modern periodic table, hydrogen was placed separately. So that there is no issue on the position of hydrogen. I mean, since it has properties similar to lithium, sodium, potassium, and it has properties similar to fluorine, chlorine, bromine, that group, it could not be placed in a single group. So might as well place it separately. I mean, if one can't have it, then no one can't have it. If both can't have it, then no one can have it. So it was placed separately. The isotopes. Now isotopes, that was the major difference between the Mendeleev's periodic table and modern periodic table. The major difference was Mendeleev's periodic table was based on increasing atomic masses, but the modern periodic table was based on increasing atomic numbers. That was the major, that is another very important question. What was the major difference? Main difference between Mendeleev and modern periodic tables. What was the main difference? It was that Mendeleev had arranged the elements in, let me write it over here, increasing atomic masses, while modern had arranged it in increasing atomic number. And this thing resolved most of the disadvantages of Mendeleev's periodic table.